So good day everyone, I'm going to show you how to perform a linear regression in SPSS. Here we got the variables numbers of farms and acreage per farm or area of land. Notice it's like a correlation as each produces scores on each variable. Now in regression we use the scores on what variable which we could call generically x, and to predict scores on some other variable which we can call generically y. To summarize, x is predictor or independent variable abbreviated with IV. So and y is the criterion or dependent variable abbreviated with dv. So let's run the regression in SPSS. So you need to go to analyze, then regression, and then linear. Click it. Here I've already set it up, and I'm going again to reset it. So the linear dialog box opens. Now notice that the way it represented here, we have dependent and independent. And again, as I said before, that our x is our predictor or independent variable. Y is the criterion or dependent. So dependent is y and independent is x. And in number of farms is our x, and acreage per farm is our y. So in other words, we will use number of farms to predict the acreage per farm. So this is our predictor. So we'll click OK. So as the result, as you can see here, we got 4 different tables of output. Here is the variable entered removed table, and the dependent variable is acreage per farm, which is here, and the variable entered is number of farms, also only 1. So next is the model summary table. There are several couple important values here, namely r and r square. R is known as multiple correlation coefficient. In simple regression, it is equal the Pearson correlation, where in fact 4.429 is the correlation between number of farms and acreage per farm. Next is the r square. So the definition is that it's the amount of variance in the dependent variable that is accounted for or explained by the independent variable. So the interpret this is, we take our 0.18 and we can turn that in percentage. That's one way to talk about, so later on. So so we take the 0.18 and convert that to percentage by multiplying by 100 and add the percentage sign. That is 18%. This means that we have 18% explanation about number of farms all alone. So in ANOVA, it will assist the number of farms is in a significant predictor of acreage per farm or not. In other words, it is statistically significant. And in regression, we can either choose it's ANOVA table or coefficient table. So notice the p-value here in ANOVA, which is significant, statistically significant. In regression, we can notice the p-value here in ANOVA 0.396, and same goes to the coefficient 0.396. So here is our p-value is again 0.396 and our ANOVA is 0.396. When we compare that to our two conditions, here you can see that false in our second condition. 0.396 is greater than 2.05, meaning that the test is not significant because number of farms is not significant predictor of acreage per farm. So written results in APA format using ANOVA table, number of farms was not significant predictor of acreage per farm. So F is, which we have the regression 1 and residual 4, and its value is, in our F is 0.9t. So the p value is 0.396, and the R square again is a model summary is 0.18. And in our using coefficient table, we have the beta, which is the 0.93, 0.43, rounded off by decimal point. And in our t, which is 95.95, in our p value is 0.396, and our R square is in the model summary, which is the 0.18. So that's all.